Welcome to today's Explainer. I am so incredibly thrilled you're joining us. Today, we're doing something really cool. I'll be acting as your bilingual science guide as we explore the fundamental building blocks of chemistry, all while simultaneously leveling up our English scientific vocabulary. It's going to be a fantastic, highly focused session, so let's jump right in.
So, here is our game plan for today. First, we'll establish the universal scientific language. Then, we'll clarify mass versus weight, explore the scale of prefixes, and finally, bring it all together to look at derived units and density. This is exactly the core vocabulary you need to totally master this topic.
Okay, let's dive into this. Part 1. The universal scientific language. Before we can even begin to perform experiments or describe the natural world, we absolutely have to agree on the words we're using.
Let's kick things off with our very first critical vocabulary term. The word is matter, materia. In scientific English, matter is simply defined as anything that has mass and occupies space. Basically, it's the physical stuff that makes up the entire universe. Now, to accurately describe matter, we have to measure it. And think about it. Just like learning standard English helps us communicate with people all over the globe, scientists realized a long time ago they needed a standard language for measurements. So back in 1960, an international agreement was reached to use the International System of Units, or SI units. This guarantees that a measurement taken in a lab in Tokyo is perfectly, instantly understood by a scientist working in London or Mexico City. Let's run through the basic vocabulary, the base units of this SI system. For length, our unit is the meter, abbreviated with a lowercase m. For mass, we use the kilogram, or kg. For time, it's the second, denoted by a lowercase s. And for temperature, the official SI unit is the Kelvin, written with a capital K. Truly, memorizing these base units is like learning the alphabet of chemistry. Moving right along to Section 2, mass versus weight. Now this deals with one of the most common false friends in scientific vocabulary. In everyday conversational English, people use these two words as if they mean the exact same thing, but in science, they are totally different. Our next foundational word is mass, massa. Mass is a measure of the exact amount of material inside an object. It's what we call an extensive property, meaning it depends directly on the amount of sample you have. It's pretty straightforward. More material simply means more mass. Here is where the crucial difference comes in. Mass is constant everywhere in the universe, but weight is actually the force of gravity pulling on that object. Imagine taking a journey out into space. If an astronaut travels to the moon, her mass, the actual physical amount of matter making up her body, stays exactly the same. So space travel is a fantastic weight loss plan, but a terrible mass loss plan. Because the moon's gravity is only about 1/6 as strong as Earth's, her weight drops dramatically, even though her mass hasn't changed one bit.
All right, Part 3, the scale of prefixes. We've got our base units, like the meter and the gram. But sometimes, those base units are simply too massive or way too tiny for what we actually need to describe in the lab.
We run into a real practical problem. How on earth do we efficiently measure the very small and the very large? I mean, a scientist really doesn't want to waste time writing out 15 zeros just to describe the width of a microscopic atom or the massive energy output of a power plant. And this brilliantly illustrates our solution. Instead of inventing entirely new words for every single scale, the SI system just uses prefixes. Think of these prefixes exactly like the sizing tags on your clothes: small, medium, large, extra large. You just attach the tag to the front of the base word to instantly change its scale, and you don't even have to do any complex math. Let's walk through this scale together. If we want 1,000 of something, we attach kilo to make a kilometer. If we want 1,000th of a unit, we attach milli to make a millimeter. When we're looking at incredibly tiny things like strands of DNA or atoms, we use micro for a millionth or nano for a billionth. And for massive things, we use mega, giga, or tera. By just sticking these short prefix labels on the front of our words, our scientific vocabulary can effortlessly shrink down to the microscopic level or expand out to the size of a galaxy. Which brings us to our final section, Part 4, derived units and density. So far, we've got our base words and our prefix modifiers. Now we're going to mix them together into compound phrases, which scientists call derived units. Since we're combining units now, we need a new word. That word is volume, volumen. Volume simply measures the amount of three-dimensional space that an object occupies. Now, what's genuinely fascinating about how we build the unit for volume is that volume isn't a base unit at all. It's actually derived by taking a unit of length and cubing it. Imagine a large block that's 1 meter on all sides. That's a cubic meter. If we break that down into a smaller cubic decimeter, it happens to be the exact same volume as 1 liter. And if we go even smaller, down to a cubic centimeter, that tiny block is exactly equivalent to 1 milliliter. So next time you hear a doctor on TV ask for 5 cc's of a medicine, they are literally asking for 5 cubic centimeters, which is exactly 5 milliliters.
Putting mass and volume together gives us our final core concept. The word is density, densidad. Density is mathematically defined as the ratio of mass to volume. To find it, you simply take the mass of an object and divide it right by its volume.
Let's picture this in the real world. Say you need to find the density of a gold nugget. First, you'd place it on a balance to find its mass. Let's say it comes out to about 51.8 grams. Then you drop that nugget into a glass cylinder filled with water. The water level rises, pushing out an amount of water that is exactly equal to the gold's volume. By taking that mass and dividing it by the newly found volume, boom, you get the density of the gold.
And this brings us to a massively important concept in chemistry. Density is an intensive property. Unlike mass or volume, an intensive property absolutely does not change, no matter how much of the substance you're holding. If you have a tiny single flake of pure gold or an enormous heavy brick of pure gold, their density is exactly the same, 19.3 grams per cubic centimeter. Because it never ever changes, scientists use density like a unique fingerprint to identify unknown materials.
So, I want to leave you with this provocative thought. Imagine astronauts discover a totally alien, unknown rock on Mars. Obviously, they can't just send the rock back via email. But by measuring its mass, finding its volume, and calculating its exact density, its intensive property, they can instantly communicate its physical identity to scientists back on Earth. Units of measurement truly are the universal vocabulary of discovery. Thank you so much for joining me in this explainer today, and keep practicing both your chemistry and your English.